Today, we're going to break down a major cybersecurity event that has governments and huge organizations all over the world on high alert. It's a story about a digital backdoor that was left wide open and the global race to slam it shut before it was too late. And wow, the news broke fast, and it was serious. We're talking about the Dutch Data Protection Authority, the Judicial Council, and even the European Commission itself, all confirming their systems had been breached. This wasn't some minor glitch. This was a coordinated hit right at the heart of European governance. So that's the million-dollar question, right? These are organizations with really sophisticated defenses. So how did attackers just slip right past them? Well, the answer wasn't a single master key. It was a whole ring of them. Turns out, at the very core of this crisis is one piece of software that countless organizations use to manage their most sensitive devices. But this software had a secret. A whole collection of zero-day vulnerabilities, all dropped on the public before a fix was even available. It created the absolute perfect storm for hackers. And the impact wasn't just limited to Europe. Nope. This thing escalated, and fast, into a full-blown global cyber alert, sending shockwaves through security teams on multiple continents. I mean, just look at this victim list. It reads like a who's who of critical infrastructure. Along with the Dutch and EU bodies, the UK's National Health Service started seeing hostile activity. Then national cyber agencies in the US, Canada, and Singapore all blasted out emergency warnings, basically confirming that attackers were actively using these flaws all over the world.
So, what exactly were these powerful vulnerabilities? To really get a handle on the attack, we first have to understand the weapons that the attackers were using.
Okay, so a zero-day. This is pretty much the ultimate nightmare for a security team. It's a flaw in the software that the vendor knows about, but they haven't had time to patch yet. The name comes from the fact that the good guys have had 0 days to create a fix, which gives attackers this wide-open window to just walk right in. It is a frantic race against time.
And in this case, we're not talking about 1 0-day. We're talking about an astonishing 13 of them, all disclosed at the same time by the Zero-Day Initiative. Now, that's a program that buys vulnerabilities from researchers. They give the software company a deadline to fix the problems, and if that deadline passes, they go public to warn everybody. For a single product to have this many dropped at once, it was just unprecedented. The software at the center of all this is called Ivanti Endpoint Manager. You have to understand, this thing is like the central nervous system for an organization's mobile devices. It manages phones, tablets, pushes out security rules, controls apps, everything. Gaining control of this system isn't just bad, it's like being handed the keys to every single mobile device in the entire company. Now, out of all 13 of those flaws, 2 of them in particular formed an absolutely devastating combination. The first one is what's called an unauthenticated remote code execution flaw. Think of it as a skeleton key. It lets an attacker run their own code on a server from anywhere in the world without even needing a password. Then there's the second one, a privilege escalation flaw. Once they're inside, this lets them become the system user, which is basically the digital equivalent of God mode on that machine, the highest level of control possible. So, how did the attackers put these pieces together? Well, it wasn't about just using one of them. It was about using them in a specific sequence to achieve a complete and total takeover.
This technique is called vulnerability chaining, and honestly, the best way to think about it is like a heist. The first vulnerability gets you in the front door, but once you're inside, you still need another vulnerability to crack open the main vault, and that is exactly what happened here.
It's a simple but totally brutal 2-step process. Step 1. Use that remote code execution flaw to get a foothold on the system. At this point, they're in, but their access is limited. Then comes step 2. They trigger the privilege escalation flaw to become that all-powerful system user. The result? Full system compromise. Game over.
So, with the full TAC blueprint now public and no official fix in sight, organizations were just exposed. You can imagine the panic. It triggered this desperate, global scramble to build defenses on the fly.
Yeah, this is the worst-case scenario. The instructions for how to break in are out in the open, and every security team is completely on their own. They can't just click Update. They have to build their own walls, and they have to do it like yesterday.
So the crucial point is that security experts rushed to publish workarounds. The advice was clear and direct. First, if you can, just rip these systems off the public internet entirely. Second, use a web application firewall. Think of it like a bouncer at the door, inspecting all the traffic. Third, apply the principle of least privilege. And fourth, block the server from making any outbound connections. That cuts off a hacker's lifeline to their command center.
You know, this whole incident isn't just about Ivanti or these specific 13 flaws. It shines this massive spotlight on a much larger and, frankly, a growing strategic problem for cybersecurity.
And that problem is with what we call edge devices. These are systems that, by their very design, have to be connected to the public internet to even function. We're talking about things like VPNs, firewalls, and mobile device managers. This constant exposure makes them a giant flashing neon sign for attackers. They're just incredibly attractive targets.
And don't just take my word for it. The UK's National Cybersecurity Operations Centre put it very bluntly. They said that these devices are highly attractive targets, and that it's highly likely we're going to see this exact same pattern of zero-day exploitation happen again and again.
And this isn't some new thing. Just last year, in 2023, the government of Norway got hacked through completely different vulnerabilities in the exact same family of Ivanti products. This just shows that attackers have identified these platforms as high-value, persistent targets, and they are going to keep hammering away, looking for any crack they can find.
Which really just leaves us with this one big lingering question. These edge devices are absolutely essential for our hyper-connected world of remote work and mobile access. But every single door we open to the outside is a potential entry point for an attacker. So as we keep building this future, how on earth do we secure the edge?